Welcome back, Focus Learners. I am absolutely thrilled to have you here for another explainer. Today we're doing a deep dive visual analysis into a surprisingly fascinating piece of kitchen industrial design. We're going to look closely at a tool that takes an incredibly common, honestly frustrating daily chore and completely transforms it through sheer engineering elegance. Because let's face it, literally nobody wants fingers that smell like garlic for 3 business days, right? So get ready, because we are about to deconstruct the form, function, and flavor mechanics of the garlic rocker.
Okay, let's dive into this. How exactly can a simple curve revolutionize one of the most tedious kitchen tasks? We all know the absolute struggle of messy kitchen prep. You're dealing with sticky, pungent ingredients, your hands get covered in oils that are just impossible to wash off, and traditional tools, well, they often require an absurd amount of hand strength just to get a usable yield. Our subject today solves this exact problem, and it does so without a single moving part, hinge, or complicated lever. It's brilliant.
Right away, the kinetic action is just immediate. The hand is firmly pressing the tool down into the wooden cutting board. It's not some static object sitting lazily in a drawer. It's a tool in the middle of performing exactly what it was built to do. You can almost feel that intense downward pressure just by noticing the tension in the hand.
Section 1. The Garlic Rocker, an overview.
Let's break down the visible design elements here. We've got a distinct dual material construction featuring this prominent U-shaped open-ended curve. You'll definitely notice the brushed metallic bottom, which is contrasted really sharply by the matte black upper handle, and finally a grid of uniform circular perforations. So the crucial takeaway here is that absolutely none of these features are accidental. Every single element is a deliberate, calculated design choice setting the stage for the tool's maximum utility.
Section 2. Anatomy of the grip, human interaction. Let's ground ourselves with a quick definition. Ergonomics is the science of design intended to maximize productivity by reducing operator fatigue and discomfort. Now, think about traditional garlic presses for a second. They usually force you into this awkward, intense pinching motion using just the fingers and the palm. That can be exhausting or even painful, especially for folks with limited grip strength. This specific U-shape throws that old pinching mechanic entirely out the window.
Now, what's really interesting about this is the user's hand placement. Notice the knuckles and how the thumb is wrapped so comfortably over that smooth upper handle. The thick, matte black material, it isn't just there to look cool. It provides a non-slip, wide surface area that easily accommodates a firm, closed-fist grip. This means you're pushing from the palm and the arm rather than squeezing with the fingers. It is a massive ergonomic upgrade.
Section 3. Crushing matrix, structural elements.
There's a stark contrast between these two components. The top handle is smooth, black, and thick, expressly designed for comfortable, prolonged human contact. But the bottom matrix is an entirely different beast. It's curved, brushed steel, highly perforated, and perfectly designed to crush and extrude. It cleanly and elegantly separates the human interface from the mechanical processing area. Basically, you hold the soft part and the hard part utterly obliterates the garlic.
The texture and the precision of the holes visible right in the belly of the metal curve are incredible. The metal has to be exceptionally rigid to withstand the whole upper body weight pushing down on it, and those holes need to be precisely uniform so the garlic is minced to a consistent size. Plus, that brushed texture actually helps grip the clove initially so it doesn't just shoot out across the cutting board the second you apply pressure.
Section 4. Mechanics of rock, the kinetic arc.
Let's move to and see how this builds into the actual mechanical process. Step 1. The user applies downward pressure from above. Because of that ergonomic grip we just talked about, they can leverage their upper body weight, not just hand strength. Step 2. They use the metal groove to pivot and rock the tool back and forth. Step 3. This rocking pivot acts almost like a rolling pin, creating immense downward force that seamlessly pushes the tough cloves right up through the metal grate.
Section 5. The final mince, mechanical results.
Because the tool rocks downward into the board, the processed garlic is forced upward. This upward extrusion is actually a total game changer. It means the minced garlic collects cleanly on the inside of the curve. Instead of scattering all over your pristine wooden cutting board and making a sticky nightmare, it pulls perfectly neat inside the belly of the tool.
And this brilliantly illustrates the genius of the U-shape. The minced garlic just accumulates right on top of the curved metal grate. Because the design is totally open-ended, there are no enclosed walls or weird tight corners, you have immediate, completely unrestricted access to the final minced product. A quick swipe with a spoon or a knife, and the garlic is ready for the hot pan, leaving the tool incredibly easy to just rinse clean in seconds.
So I want to leave you with this provocative final thought. Is this simple, dual material curve the ultimate evolution of kitchen prep? By breaking down the design of this tool, we've seen a pretty much perfect marriage of ergonomics and mechanics. We've seen how smart industrial design can take our human limitations into account and build a shape that just does the hard work for us. It really makes you wonder, what other everyday objects could be completely reinvented with just a slight change in perspective and a really good curve. Thanks for learning with me today, and I'll catch you in the next explainer.